Okay, so video request and the solution to it. Can you explain the use of semicolon, comma, colon, comma, semicolon, full stop, and single apostrophe in MATLAB, as in when to use them, and also difference between A star B and A dot star B, was round and randy. Okay, so let's create a new script. So let's name it script Wale. All right, so let's start with the colon. Let's create a variable. The colon, so let's say x equals to, the colon is used to separate your argument into your arrays. Okay, MATLAB sees everything as arrays, or matrices. Sometimes it calls arrays matrices, but arrays are sort of the one line numbers listed in a line. For instance, so let's say we have 1, 2, 3, 4, 5, 6. This is an array. Okay, and each position is an index. So if I want to access, let me not use 1, let me use, let's say 3, 5, 4, 9, 6. If I want to access 9, right, the index of 9 is 3. It is at the third position. Okay, that's how MATLAB sees things. So MATLAB sees things in arrays. Then if you come down, like let's say you have some numbers down here. Okay, this is not in the right proportion, but it's not in alignment. But let's say you had numbers down here, you didn't have this x here. Okay, and you have, this has become a matrix. Okay, so you have, this is a 2 by maybe 1, 2, 3, 4, 5, 6 matrix. Okay, so row, 2 rows and 6 columns. That's how MATLAB sees things. So you should keep this thing in your mind. Always when you're coding, keep this thing in your mind. MATLAB is about arrays and matrices. Now, the colon, it is used to create a sequence of vectors. Okay, and it also helps us to space out in even intervals. For instance, so let's say r, we are creating a variable r is equal to, let's say 1 colon 5. So we want to create numbers. It's going to add +1 because it didn't specify. Okay, so this is the function of the, you get it. So R has created an array of 1, 2, 3, 4, 5, like that. But if you put a number in between, you specify, let's create a new one, a new variable. Okay, so when you're coding, you shouldn't be repeating variables like that. You said R is this, then you should create a new variable for your next statement, unless you need to change the value of one variable for some particular equation or whatsoever it is. Okay, so let's say R2 is a new variable. Okay, and variables are just spaces containing, so you store your numbers, your data, your integers, your strings. Okay, they are just storage places. So always the variable is at the left side, then what you want to store into the variable is at where? The right side. So let's say R2, let R2 be, let's start from 0 colon. Okay, we want to move +2 to, let's say 20 times. Let's run this code. So you see the output 0, 2, 4, 6, 8, 10, 12, okay, 14. So that's the function of the colon. It helps us to create sequence of vectors. Vectors are the same as the arrays. Okay, vectors that we see, they are the same as arrays. Help us to create sequence of vectors and helps us to do what? Space them in even intervals. Okay, now the colon, the semicolon is used to end statement. Okay, and if you don't want to display the statement, the semicolon helps. So you just end it. So put in the semicolon here. Okay, so let's try to display something. Let's create something new. So let's say W is equal to what? Let's say W is equal to 6. We want to display this. Let's come again. Let's say E is equal to what? 2. But we don't want to display this. Let's run this code. So W was displayed, but E wasn't displayed. That's the function of the semicolon. It helps you stop your output from displaying, unless you use display itself, DISP, right, or fprintf. For them, whatsoever you do, they will display your output. And let's move to the comma. So the commas help you to separate input. Okay, the input are also called arguments. Okay, so whenever you create a function, it accepts inputs. The inputs are also called arguments. Or whenever you're creating a matrix, for instance, let's create one. So let's say we have let's delete this. Let's say we have y is equal to, we are creating a matrix. Okay, let's say let's manually create a matrix. So we have to comma 3, comma 4. Okay, then we bring the semicolon. This time around, the semicolon is serving a different function. You'll get to that, don't worry. Let's see, 4, comma 8, comma 9. We close the matrix. So we want to create, this is going to create a 2 by 3 matrix. What's a 2 by 3 matrix? A matrix that has 2 rows, 3 columns. Always the rows are stated first, then the columns. Okay, so you usually see representations of matrix like 6 times 8, 4 times 2, excuse me, or you see R times C, which is row times column. So this our matrix Y has 2 rows. Okay, so let's look at the numbers. So 2, comma 3, comma 4. The next how do I say it, display, or the next character after the 4 is not comma, it is what? Semicolon. The semicolon is used to move on to the next row, right? So let's try to see what this will print out. So we have 2 rows here, because after the semicolon we go to the next row to get 4, 8, what, and 9. So that's the function. You see the output over there, that's the function, the output. So Y is equal to what? 2, 3, 4 in the first row. Then in row 2 you have 4, 8, 9. That's the function of what? The semicolon in this particular statement. It is creating a new row. So if you bring another semicolon, you can create a third row. Now let's look at dots and the star and the dot star. Now the star is used for multiplication of matrices. For example, let's create another matrix again. Let's say U is equal to, let's just do 2 by 2, not to complicate things. Let's say U is equal to 2, 3, comma. Now you are aware of what's happening. 4, let's just use small numbers. You are just practicing something. 4, 1. Now let's create another matrix. Let's call it U2. Okay, that is our variable. Is equal to, let's say small numbers. Let's say 0, comma 1, semicolon 2, comma 3. So what output is this going to give us? We are going to get 2 by 2 matrices, right? Because we have 2 rows and 2 columns. So I'm going to get something like 2 squares, right? So let's display them. So we have U1 as a 2 by 2 matrix, and we have U2 as a 2 by 2 matrix. Now what does the star do? The star just multiplies. Okay, so the star is used to multiply, but the star performs, there are 2 types of multiplications in MATLAB. Okay, and in your math class we don't multiply matrices as we multiply normal numbers, right? We have ways, we have formula for multiplying matrices. The row times the column. Okay, for that one you can search for that one, right? The star does matrix multiplication. Okay, so U star, because U is a matrix, note that. Let's store the answer in a variable called G. So U, okay, use small U star, what's big U2. Okay, this is going to give us a different answer from U dot star big U2. You will get to understand that. Look at this display. So we have G is 6, 11, 2, 7. This is matrix multiplication. Okay, when you follow the rules for multiplying matrices, this is what you're going to get. But let's create another variable. Let's say A is equal to U dot star or U2. This time around, it's going to multiply element wise. So note that that's the difference between the star alone and the dot star U2. The dot star does element wise multiplication. What is element wise multiplication? It multiplies the corresponding elements just like that. It doesn't follow matrix multiplication rules. It just does, it multiplies what it sees. Okay, so just like your I and J, I1 multiplies I2, J1 multiplies J2. Let's look at the output. So you see the outputs. Look at your matrices again. U1, look at row 1, column 1. Look at that. We have 2 U, and look at U2, row 1, column 1. We have 0. When you come here, forget the G, because it's matrix multiplication. There's a formula you have to use. row times column, some formulas. But look at the A. It is doing element-wise multiplication. So 2 times what? 0 is what? 0 in row 1, column 1. Now look at 3 times 1. Okay, so row 1, column 2. 3 times 1. You get it? We have 3 here. Now let's come down here. Row 2, column 1. 4 times row 2, column 1 of U2. 2. Now come to row 2, column 1 of A. 8. You guess it? 4 times 2, 8. Then the last one, you can verify for yourself, right? So that is what the dot star does. It does element-wise multiplication. It multiplies elements respectively according to their positions. But multiplying two matrices with star like that, that's matrix multiplication. Now, rand stands for random. Rand. It just creates random numbers. Now, so we have rand, shortened form of random. Rand takes arguments. So if you don't give it any arguments by default, it creates random numbers between 0 and 1. So let's say rand for 2. This is going to create what? A 4 by 2 matrix. Remember, matrices are indicated by their rows and columns. Okay, so row first, R, column second, C. So 4 rows, 2 columns. So I'm expecting a matrix, right, with numbers between 0 and 1 of 4 rows and 2 columns. That's the function of rand. It creates random numbers. Okay, random numbers between 0 and 1 with a uniform distribution. Look at that. So we have 4 rows, 1, 2, 3, 4, and 2 columns. That's the function of rand. It generates a random matrix for you. Okay. Now what about randy? It's in randy that you can specify for yourself. So let's cut out the display of rand. We are focusing on randy. So this is randy. So in randy, you can specify what you want. Okay. So let's say we have 4, 2 here. This time around, randy is going to create a matrix, okay? A matrix, I think 2 by 2 matrix of 4 of digits, okay, between 1 and 4. That's the function of randy. So between 1 and what you've put there as your argument. Okay, so between 1 and 4, 2 by 2 matrix, okay? That's the function of randy. Then I think you can give it another argument. This time around, it's going to create numbers between 1 and 4 of a 2 by what? 4 matrix. Okay. So we have a 2 by 4, 2 rows, 4 columns. So if you put, let's say, 30 here, 30, it's going to create the random numbers between what? 1 and 30 of 2 by 4 columns. Let's do it 4 by 4. So we have something looking like a square. Okay, so numbers